Hi everyone, so this is going to be our final lecture of this particular chapter. So we are going to see some important points. So the first point is conservative vector field. What do you mean by conservative vector field? So there is a vector field F. Now in this vector field F, you need to walk from path from point A to point B. So there are multiple ways of going from point A to point B. I can go like this as well, right? I can go like this as well, right? I can go like this as well, right? So this path I am calling as C1, this path I am calling as C2, this path I am calling as C3. So if you are going from C1 path, what will be your line integration? F dot dl C1 path. If you are going from C2 path, what will be your line integration? So here I am writing dl1 because dl could be different for all these paths. So here I am writing dl2. If you are going from C3 path, then what will be your line integration? dl3. Like you are taking small dl3 here, dl2 here and dl1 here. Now if the vector field F is conservative, then all will be equal. That no matter from which path you walk, if you are going from point A to point B, all these will be equal. You can walk from C1 path, C2 path or some any other path. You can go like this, like this, like this, like this, and then eventually you are coming to point B only. You walked anywhere, eventually if you are coming from point B only, then that line integration will also be equal. So if my vector field F is conservative, then line integration across any path between 2 points will be same. If my vector field F is conservative, then line integration across any path between 2 points will always be same. So this is what we mean by conservative vector field. Okay. Now try finding the answer of this question. What I am saying, the vector field F is conservative, then what will be the value of closed line integration? You need to find the value of closed line integration along the path C. This is the path C that has been shown. Curve C, or you can say, or path C, you can say. This is your path C. You need to find the value of closed line integration. So what I need to find? I need to find F dot dl along the curve C. So I can break this curve into two parts, C1 and C2. Across C1 I am taking small length dl1. Across C1 I am taking small length dl1, and across C2 I am taking small length dl2. So F dot dl, what that would be? C1 F dot dl1 plus C2 F dot dl2. In case of C1, from where to where you are going? From A to B. So can I write in this manner that I am going from A to B? And in case of C2, how you are going? You are going from B to A. So can I write in this manner? B to A. Now what I can write? A to B F dot dl1 minus A to B F dot dl2, right? I have just interchanged the limit. If I interchange the limit, then minus sign will come. If F is conservative, if F is conservative, if F is conservative, so let's call this as I1 and this as other one as I2. Then what will happen? I1 will be equals to I2. What I am saying is that, let's not write it here. This thing I am calling as I1 and this thing I am calling as I2. So if it is conservative, then I1 is equals to I2. Then what will be your F dot dl? 0. Say yes or no. So if my vector field F is conservative, then my closed line integration is 0. We have got two statements now. If your vector field F is conservative, then your open line integration will not depend on path. If your vector field F is conservative, then your open line integration will not depend on the path and your closed line integration will be 0. Is it obvious as well? Like I am going from here to here, then coming back. So both integration will be equal but opposite in sign. So answer will be 0. Right? So vector field F is conservative, then This is path independent. Open line integration is path independent, and your closed line integration is 0. Okay. Now one more thing, if your del cross f is 0, then what will happen? Closed line integration can be replaced by this, right? Closed line integration f dot dl can be replaced by this del cross f dot ds. Now my del cross f is 0. Here I can put double sign. Okay, I need to change the color of the fan. Here I can put that double sign. So del cross f is 0. So what I will get? 0 only. F dot dl is equals to 0. So if my del cross f is 0, then certainly my vector field is conservative. Okay, very important statement. If your del cross f is 0, then your field is conservative. Now secondly, if I say my field is conservative, I am saying that my field is conservative. If my field is conservative, then what is the bottom line? What is the first statement? If your field is conservative, that your f dot dl is path independent. What is the second statement? That this is 0. So if your field is conservative, then this is 0. Now does that represent that your del cross f will also be 0? No. If I am saying that my closed line integration is 0, if my closed line integration is 0, then is it necessary that your del cross f will also be 0? No. Why is that so? Because what is your f dot dl? That is del cross f dot ds. Now what if, let's just say, my del cross f is coming out to be 5 ay cap and my ds is coming out to be dx dy az cap. So what will be your del cross f dot ds? 0 only. Del cross f dot ds, what that would be? 0 only, no? Here del cross f is not equal to 0. Here del cross f is not equal to 0. Del cross f is 5 ay cap and your ds is dx into dy az cap. If you do del cross f dot ds, what you are getting? 0. That means your closed line integration is 0. If your closed line integration is 0, that means certainly the vector field f is conservative. If your closed line integration is 0, then vector field f is conservative. But your del cross f was not 0. So what did you understand from here? That if del cross f is 0, then certainly the field will be conservative. But if the field is conservative, then it's not necessary that your del cross f has to be 0. Are you getting this point? So here I am not writing and vice versa. Like, what do you mean by vice versa? That this statement can go from here to here and here to here as well. No, it cannot come back. If del cross f is 0, then certainly vector field will be conservative. But if the vector field is conservative, it's not necessary that your del cross f will be 0. Okay, so this is what I have written. If del cross f is not equal to 0, then also field can be conservative. Or what I can write, forget about this statement. Here I can write down that what if del cross f is perpendicular to ds. Let del cross f be 5 az cap and ds be 5 ay cap. Let's take ay cap and ds be dx dy az cap. Then what will be the value of del cross f dot ds? What will be the value of del cross f dot ds? So 5 ay cap dot dx dy az cap, and that will be equal to 0. Here f dot dl is equal to 0. That means field is conservative, but del cross f is not equal to 0. So blindly you will never apply del cross f equals to 0. Okay, if someone is saying that field is conservative, then del cross f is equals to 0. Like 95% of the students are going to do this mistake that if field is conservative, del cross f is equals to 0. No, if del cross f is 0, then certainly field is conservative. So what is the statement we can write? If field is conservative, then del cross f may or may not be 0. May or may not be 0. Okay, if the field is conservative, then del cross f may or may not be 0. Very easy statement. Just one thing you need to remember, that it would be path independent. If it is path independent, then closed line integration will be 0. If closed line integration is 0, then it's not necessary that del cross f has to be 0 as well. But if del cross f is 0, then certainly your closed line integration will be 0. So this is the summary of everything that we have studied till now. In the past 10 minutes, this is what we have studied. I hope it is crystal clear to you, right? Let's move to the next simple things. So if someone is saying that the vector field is irrotational, like there is no rotation, what does curl show? Curl shows the rotation, right? Curl shows the rotation. I hope you remember this, right? So if they are saying it is irrotational, that means curl is 0. Okay, if a vector field is irrotational, that means curl is 0. And if they are saying that vector field is solenoidal or divergence-less, that means it will be that divergence will be 0. Irrotational, that means curl will be 0. If they are saying it is solenoidal or divergence-less, that means its divergence will be 0. Okay, so this term is used, solenoidal. We will study about it when we study Maxwell equation. Okay, when we study Maxwell equation, I will tell you the actual meaning of this, why it is known solenoidal, why we have given the term solenoidal, that I will tell when we study Maxwell equation. Okay, so if they are saying it is solenoidal, that means divergence will be 0, and if they are saying it is irrotational, that means curl will be 0. So let's solve a very simple question. So vector field A is solenoidal, you need to find the relation between alpha and beta. So basically what you are going to put, del dot A is equals to 0. Can you find del dot A? Yes. Del by del x, then you need to differentiate this term with respect to x. So what you are going to get? 2 alpha xy. Then differentiate with respect to y. So z minus 2 beta xy. Differentiate this with respect to z. So minus z. And that is equals to 0. So what is happening? This z and this z is getting cancelled. Xy is getting cancelled. So alpha is equals to beta. That's the relation. Okay. Very straightforward question. In 1 mark, these kind of questions can be asked. Solenoidal means your divergence is 0, and irrotational means your curl is 0. Let's solve some questions now. Okay. So you can take it as an assignment, but you can try solving it on your own. Otherwise, you can see the solution as well. Okay. These are some good questions which I have picked. These are gate PYQs only. So some good questions are there. So you can try solving it on your own. This should be solved by you. Okay. This should have been solved. You can solve it on your own. Let's try. Okay. So what we need to find? We need to find this thing. Line integration we need to find, but this is a closed curve, right? This is a closed curve. Line integration I need to find, but I can see that it is a closed curve, right? So this is what I need to find. Closed curve x dy minus y dx. From here, can you let me know what would be my vector A? What is my vector field? Can you tell me from here by looking at it? What is my vector field? My vector field is x ay cap minus y ax cap. Did you understand this point? Because from here, what will be my ds? ds will be dx ax cap plus dy ay cap. Sorry. Wait a minute. Sorry, not ds. Really sorry. dl. Really sorry. dl. Not ds. Sorry. dl. So dl will be dx ax cap plus dy ay cap. This will be my dl. If I do a dot dl, what I am getting? A dot dl. So ax cap will be multiplied with ax cap. So minus y dx plus ay cap will be multiplied with ay cap plus x dy. This is what you are getting. So this is what they have written. So from the expression as well, you should have the habit to get the vector A. So in the conclusion, my vector A is coming out to be minus y ax cap plus x ay cap. Since this is a closed line, If it is a closed line, that means Stokes is applicable. Stokes theorem is applicable. So what I need to find? A dot dl. So how will I get A dot dl? A dot dl I will get from del cross A ds. So first my target is to find del cross A. So how will I find del cross A? Del cross A. What is the formula that I have told? Ax cap, ay cap, az cap. Ax cap, ay cap, az cap. Del by del x, del by del y, del by del z. Minus y, x and 0. Minus y, x and 0. So ax cap 0 0 0, ay cap 0 0 0, az cap. If you do az cap, what you are going to get? Az cap you are going to get 1 minus 1, 1 minus minus 1, 1 minus minus 1, so 2 az cap. So your answer is 2 az cap. So your del cross A is 2 az cap, right? What is your ds? Directly you can see. What is my ds? First see the rotation. Rotation is in this direction. So ds will be az cap. Direction will be az cap. And what is constant here? Z equals to c. The equation of the plane is z equals to c. Because x and y are variable, z equals to c is the equation. So what will be your ds cap? That would be plus minus az cap, but I will take plus az cap. Why is that so? Because I will see the rotation. Rotation is in this direction, so plus az cap I am taking. So it will be plus az cap. And what will be your ds? So now my ds will be dx dy az cap. Okay. So now what will be my A dot dl? This is what I need to find. So my A dot dl will be 2 az cap into dx dy az cap, surface area. Okay. So from here we take the strip, right? Now we take the strip, right? But do we need to take the strip in this example? Let's see it. What will happen? Az cap dot az cap will be 1. So what we are going to get? 2 then dx dy. If I was having some function of x here, let's just say if it was this kind of function, if it was there, if I need to calculate the integration of this, then I would have taken a strip here. But what this function is saying, what this integral is saying, this integral is saying that simply the surface area of the enclosed surface. From the closed line, how much surface you are enclosing, just tell me the surface area of that. To integration dx dy. That means they are just asking the surface area of this much enclosed space. So what that would be? Are you getting this point? This is very simple. This was very simple. If you had to take a strip, then it would be difficult. Like this is how I would be taking a strip. That I am walking along y now. So y limit I would have put, then x limit I would have seen. Then I would have to go to some x cos theta, y sin theta, these kind of things I need to do. Then it would be a bit complex for me. But now it is easy because it is just telling the surface area. So what is the surface area? That is, first you can see this is a rectangle. So surface area of this rectangle is 3 into 2, 6 plus, then this is a half circle. Half circle, or what do we call it? Semicircle. So pi r square by 2. So pi r is 1. So pi by 2. So pi r square by 2. So what you are getting? 12 plus pi. That's the answer. Okay. So the trick here was, this was the simple surface area it was saying, because there was no variable of x or y here. So if there is no variable of x or y, this is simply saying you to calculate the surface area. Right? That's it. Let's see the next one. This is a good question. So first task will be to find the vector A here. Can you find the vector A? Yes. So I found the vector A, which is y square 2ix ax cap plus 2xy plus x square ay cap. What will be my dl here? dl is dx ax cap plus dy ay cap. What do you actually need to calculate? A dot dl. Will I write the close sign here? No, because this is not a closed. This is not a closed line. This is an open line only. there is only one line. There is only one line, which is this. If the scene was something like this, that you are going from here to here, then here to here, and then here to here. If this was the scene, then it would have been a closed line. But this is not a closed line now. This is an open line only. So A dot dl I will apply. So here what will happen? Stokes not applicable. Okay. So what I need to do? Now I need to perform the operations. So what did I tell you? That always what you are going to do, you are going to assume an angle theta with respect to x-axis, right? We will solve it. Like, I know what kind of problem will come in front of you. Okay, there will be some problems. What that would be? So what will be your x? X will be 3 cos theta, right? And what will be your y? Y will be 3 sin theta. What will be your dx? Dx will be 3 minus 3 sin theta d theta. And what will be your dy? Dy will be 3 cos theta d theta. Okay. Now let's calculate A dot dl. So what you are going to get? Y square, which is 9 cos square theta. Y square is 9 cos square theta plus 2yx, which is 18, you can say 9 sin 2 theta. It will be 9 sin 2 theta. What did I do here? Look, what did I need to find first? Y square. Y square was 9 sin square theta. Then I need to find 2 into y into x. Y is 3 sin theta and x is 3 cos theta. So from here what you are getting? 9 into 2 sin theta cos theta, which is sin 2 theta. Okay. So 9 sin 2 theta I have written. And then dx. So 3 sin theta is there. 3 sin theta d theta. Along with that there is negative sign plus. Along with that there is negative sign plus 2xy. So 9 sin 2 theta. 9 sin 2 theta plus x square 9 cos square theta into dy 3 cos theta. 3 cos theta d theta. Okay. So are you getting anything common? Yes, you are getting anything common as well, but do you really think this integration is easy? What will be the limit? Limit of theta? Limit of theta is from 0 to pi by 2 because it is going in one quadrant only. Now, will you be able to solve this integration? Tough to solve. Tough integration to solve. Yeah, we can solve it. Certainly we can solve it, but it is tough to solve, right? So what did I tell you? I'm gonna tell you one thing. In the last lecture, what did I say? That I'm gonna tell you one thing to tackle these kind of problems. So whenever you see these kind of problems where such complex expression is coming, so what you will do there? You will calculate curl of A. I am not applying Stokes theorem here. I am calculating curl of A. Why I am calculating curl of A? In this kind of situation, calculate curl of A. If curl of A is 0, if you get curl of A is 0, then what does that mean? If I get curl of A is equals to 0, that means certainly my vector field is conservative. If I get curl of A is equals to 0, that means A is conservative. And if A is conservative, then I do not need to follow this path. If A is conservative, then I do not need to follow this path. The thing is, I need to go from point A to point B. If my vector field F or vector field A is not conservative, then I can go from A to B using any path. So better I will go like this. It will be easy for me to calculate. Are you getting this point? How I will go? I will go like this. So it will be very easy for me to calculate. So whenever you see a circle like these kind of problems, x square plus y square, and then you know that I need to apply sin theta cos theta here. And just as you see this kind of expression, so without even solving this much, you will get to know that there will be something complex. If I see this question in the examination, what I would be thinking that, okay, x equals to 3 sin theta cos theta, then I will put a lot of values here. It will become very complex. The expression will be very complex. Certainly it can be solved, but a lot of sinusoid, cosinusoid formulas you need to apply here. Like trigonometric formula you will need to apply here. Certainly it can be solved, but you will require good amount of efforts here. So what I would be thinking in the examination, let's try doing del cross A. If it is coming 0, I am not applying Stokes theorem here. If it is coming 0, because Stokes theorem is not even applicable, so I am not applying Stokes theorem. If my del cross A is coming 0, that means certainly my vector field is conservative, and if my vector field is conservative, then I do not need to follow this path. I can go from here to here as well. Okay. So using this formula, it is very tough to solve, but this kind of aptitude I can use in the examination. That complex expression will come. So first let's try finding del cross A. So if I find del cross A, what I'm gonna get? Ax cap, Ay cap, Az cap, del by del x, del by del y, del y del z. So y square plus 2ix, y square plus 2ix, y square plus 2ix, and then 2xy plus x square, 2xy plus x square, and then 0. What you are getting here? First you do with ax 0 0, then you do with ay 0 0, then you do with az. What you are getting here? You are differentiating with respect to x. So 2y plus 2x minus, then you are differentiating with respect to y. So 2y plus 2x. So what you are getting? 0. Now if you are getting this as 0 in the examination, you will be the happiest person on the earth, right? Here del cross A is equals to 0. What does that mean? A is conservative. That means I can follow any path now. I do not need to follow this path from A to B. I do not need to follow path C. I can follow any other path. So what I will write? C A dot dl. It will be equals to, I need to go from point A to B, A dot dl, using any path. Using any path. So how will I go? What do you think? Which I already told you, which is the easiest path for me. This is my B, this is my B, this is my A, sorry. This is my B. Look, there are a lot of ways how you can go. You can go like this as well. Right? You can go like this. From A to B you need to go. You can go like this as well. But here yx function will come. So I will try to avoid this. I will go in this manner. Here to here, then here to here. This is how I will go. So eventually I need to reach till point B. So from A to here I will go, then from here to here I will go. So here I am assuming small path dl1, here I am assuming small path dl2. This was your x, this was your y. So what is your dl1? That is your dx ax cap. And what is your dl2? That is your dy ay cap. Right? Now I need to calculate a dot dl1. Okay, so what that would be? This is my, where is my vector A? This is my vector A dot dx. This is my vector A dot dx. So y square plus 2ix dot dx. Y square plus 2ix dot dx. But for dl1, y is equals to 0, no? For this path, here y is equals to 0. Here in dl1, if you are working on x axis only, then y is equals to 0. So I will put y equals to 0 here. So what you are getting? 0 only. A dot dl1 I am calculating. On dl1 y is equals to 0 and on dl2 x is equals to 0. On dl2 x is equals to 0 on dl1 y is equals to 0. So here I am getting 0. What about A dot dl2? So what I need to find? A dot dl2, and in dl2 what I am gonna do? dl2 dy into ay cap. So I will only look at ay cap. Which is my ay cap? 2xy plus x square. 2xy plus x square into dy. Okay. So what is the scene here? Here your x is equals to 0. In dl2 x is equals to 0. If you put x equals to 0 here, if you put x equals to 0 here, what you are getting? 0 only. So what is the final answer? A dot dl, that is coming out to be 0 plus 0, which is equals to 0. So this is the final answer. Okay. So if you solve this integration using trigonometric formula, here also you will get 0. But this is very clear that if complex expression is coming, then there is high chance that your del cross A will go to 0 only. And if it is going to 0, then you can follow any path. You need to reach from A to B by using any path you can reach there. Well and good. I hope this is something new you have understood here. Let's solve the next one. Very easy question. This kind of question we have already solved. So what we need to find? Divergence of r square and gradient of ln r. So divergence of r square. What is the gradient of ln r? 1 by r ar cap, right? I hope you remember it. Simply do the differentiation and then ar cap. So divergence of r into ar cap you need to find. So what that would be? Basically you need to find, let's just say my vector a is a r ar cap. So you need to find del dot a. What that would be? This is in spherical coordinate system. So 1 by r square d by d, del by del r I need to write. Del by del r, del by del r square is there. Here also r square will come. This is just a formula, just a question based on formula. You should remember the formula. What was the formula? 1 by r square del by del r Vr plus 1 by r sin theta del by del theta sin theta v theta, right? Plus 1 by r sin theta del by del phi v phi. This was the formula. I told you the trick as well, how to remember it. One error will be there here, also one error will be there. Whatever the error is there, that will be applied here. Whatever the error is there, that will be applied here. So, and what is AR here? R only. So this is what you are getting. 1 by r square d by dr r cube. So 1 by r square into 3r square. So del dot a, what you are getting? R square get cancelled, 3. This is the final answer. Very easy question. These kind of questions should have been solved. Okay. Let's see this one. A very good question. Very good question. So del cross f dot ds you need to find. So f function is given and what s represents? S represents the portion of a sphere x equals to y equals to z equals to x square plus y square plus z square equals to 1 for z greater than 0. For z greater than 0. So how will you make the diagram? It is representing only for z greater than 0. This is your x, this is your y, this is your z. Z should be greater than 0. So this is what it will represent. Right? This kind of hemisphere you will get. Z greater than 0. Xy can take any value. Sorry, x square plus y square plus z square is equals to 1. So what will be this length? 1, 1. What will be this length? This length will also be 1. And this length, upper length will also be 1. So let's see the method 1. What we need to calculate? Del cross f dot ds. So first find del cross f. So what will be your del cross f? So del cross f. So pause the video or just fast forward it and then find del cross f. 1. So Ax cap plus -1. No, 1 only. For Ay cap 1 plus Ay cap plus Az, then this will be 1, this will be 0 plus Az cap. So this is what you are getting as del cross F. This is your del cross F. What will be your ds? What will be your ds? What do you think? S represents the portion of sphere. Basically, this is your S. Upper portion. This is your S. Like this is my S, the upper portion of the sphere. Okay. So this is my S. So what will be the equation of this line? On this surface, what is constant? R is constant, right? Theta phi is changing from 0 to 2 pi. Theta is changing from 0 to pi by 2. Theta is changing from 0 to pi by 2. Phi is changing from 0 to 2 pi. But R is constant on the complete surface. So equation is R equals to constant. Equation is R equals to constant. So what will be your ds cap? Okay. So going outward from the sphere. Like basically, if this is your radius, then my direction will be AR cap. Going outward from the sphere. So this will be my direction, which is AR cap. Okay. What will be my ds vector then? So r d theta, r sin theta, d phi. This we know. Sorry, dr, r d theta, r sin theta, d phi. So dr will not come in action. These two will come in action. So what will be the answer? R square sin theta, d theta, d phi, AR cap. Right. Now what I need to calculate? Double integration is there, no? Okay. One integration they have put, they can put double as well. So del cross F dot ds. So Ax cap plus Ay cap plus Az cap into R square sin theta d theta d phi AR cap. This is what you are getting. So basically dot product is there between Ax dot AR. What you are getting here? Ax cap dot AR cap plus Ay cap dot AR cap plus Az cap dot AR cap. R square sin theta d theta d phi. Okay. Limit you need to put of theta and phi. So theta is going from where to where? Theta is going from 0 to pi by 2, right? Theta is going from 0 to pi by 2. And what about your phi? Phi is going from 0 to 2 pi. So limits have been put, which I will put later on. But these dot product you need to find. Will you make any matrix here? I have told the matrix method as well, that here you write Ax, Ay and then x equals to r sin theta cos phi. So that also you can do. But did I ask you to remember something? Ax dot ar, can you visualize it? Ax dot ar, r sin theta cos phi. Are you getting this point? Ax dot ar, do you remember it directly? First I will take the component on xy plane, then along x-axis. So r sin theta cos phi. So what is the value of Ax dot ar? Sin theta cos phi. Sin theta cos phi. What is the value of Ay dot ar? Sin theta sin phi. And what is the value of Az dot ar? Az dot ar, simply cos theta. That's it. Did you understand this point? What did I do here? I hope you are understanding, or you can make the table as well, right? Okay. R square sin theta d theta d phi. Anyway, we will have to solve it. I guess only the final one will come in action. Because here theta is equals to 0 to 2 pi and sorry, phi is equals to 0 to 2 pi and theta is equals to 0 to pi by 2. So sin theta cos phi, sin square theta cos phi r square d theta d phi. So what is the first term you are getting? R square sin square theta cos phi d phi. R square sin square theta cos phi d theta d phi, or better I should have written r square d theta cos phi d phi, right? Cos phi d phi, sin square theta d theta r square. R is constant here, so why I am taking r value? R is constant, r is equals to 1. R is equals to 1. Here r is equals to 1. So r equals to 1 I will put. So forget about r is equals to 1. Again I am putting here r is constant, which is equals to 1. So here 1 I will put. So theta limit theta will get and phi limit phi will get. So theta limit theta will get and phi limit phi will get. So what is the limit of phi? Phi is going from 0 to 2 pi and theta is going from 0 to pi by 2. I don't know about this value, but I know the value of this 0 to 2 pi. Cos phi 0 to 2 pi. What will be the value? 0. Did you understand what did I do here? This value will be 0 only, no? That's it. Very easy. Here also r square is 1. So sin square theta sin phi will come. Sin square theta sin phi d theta d phi. So sin square theta d theta. So theta value is going from 0 to pi by 2. And then what will come? Sin phi will come. Sin phi will come. Sin phi d phi. Sin phi d phi. With the limit of phi from 0 to 2 pi. What will be the value of this? 0. This also I know. Right? This has also gone to 0. Last one. What is the last? Cos theta sin theta d theta d phi. So what you are getting? Cos theta sin theta d theta d phi. Limits we will put. Theta is equals to from 0 to pi by 2 and phi is equals to from 0 to 2 pi. So this we will solve now. So what I can do? 1 by 2 I can take common. Then sin 2 theta d theta with theta being from 0 to pi by 2. Did you understand what did I do here? I multiplied 2 and divided by 2. So 2 sin theta cos theta will be sin 2 theta. So 1 by 2 0 to pi by 2 sin 2 theta d theta. Now phi 0 to 2 pi d phi. 1 by 2. What this will become? Cos 2 theta. It will be negative here. Negative sign will come, but I am changing the limit from pi by 2 to 0 and divided by 2 will also come. And what this will happen? This will become 2 pi only. So cos 0 is 1, this will be 2 only. So if you solve this, you are going to get pi as the answer. So answer is pi. Okay, you can just solve it. Cos 0 is 1, cos pi by 2 into 2 cos pi. So 1 minus 1, that will be 2. 2 by 2, that will be cancelled. 2 into 2, so answer is pi. So this is the answer. This was your method 1. क्या हो गया यार? ये मोबाइल में यार कभी भी एनी टाइम दिस Google will start working. Siri is not my friend. Okay, so this was the first method. This is how you could have calculated del cross f dot ds. Del cross f dot ds. This is how you could have calculated. Now what will be the method 2? Method 2. One more page should be added. I need to find del cross f dot ds, right? Is it a closed surface? No, sorry, I should not say closed surface. Is it a like it is made from closed line only, no? Is it a closed line? Can I say it is a closed line? Yes. This is made from closed line only, no? This is a closed line. This is also a closed line. It is made from closed line only. So I can say it as a closed line. From closed line, you are enclosing some surface. So can I apply this Stokes theorem? Inverse Stokes theorem. We call it inverse Stokes theorem. So what I am applying? Just the inverse of that. What is the inverse of that? F dot dl. Now which curve I will take? Which curve I will take? Complete curve you need to take. You need to work on the complete curve. How you will work? Like you go from here to here, then you work on the complete sphere. Basically, these are the lines. First you work on the line. This line I am talking about. First you work on this line, then you need to work on the sphere as well. So this is how you need to work. Now in these kind of questions, what you need to do? First, I am telling you the method that how you should calculate. You need to calculate f dot dl, but dl is not straightforward here. This is not some closed line here, nothing like that. Like this pair or some, sorry, this some circle or some rectangle or some triangle. This is not there. It is a sphere. Below there is a line, and then upward there is a line. So how will you define dl? How will you define dl? So in these kind of questions, what you need to do? You need to think that, sir, this is my hemisphere. If I put that on earth, if I put this hemisphere on earth, what it will make? It will make a ring, right? If I put that hemisphere on a sand, on a layer of sand, what it will make? It will make a ring. So that will be your dl. Now why that is the dl? Because the thing happens is that like it will be very tough to explain. So this is only you can remember that if I put that on earth, then the ring will be my dl. Why is that so? Because all the dl component will get cancelled here. Can you try imagining it? This pair is symmetric. Only think about the upper surface. Don't think about the ring. Only think about the upper surface. So whatever that you see ahead, the same thing you can see back as well. So all the dls will be getting cancelled. Whatever the dl component come here, that will be getting cancelled. These all will be getting cancelled. So all the dl component of the closed surface will be getting cancelled. Only you need to see at the earth, which is this ring only. So what you will remember, if these kind of questions are coming for inverse, for applying inverse Stokes theorem. So there what you will think that, sir, if I put this on a sand, what I will get? I will get a ring. So only for ring I will calculate A dot dl or F dot dl. Otherwise you could have solved in this manner as well. This is your del cross F. This is also not tough. This is also not tough. This is also easy. If you have studied coordinate geometry in a good manner, you will be able to solve it very quickly. If you have good amount of concept, right? But one more method is there, that just you take the projection. It is like a projection only. So what will be the projection of this particular hemisphere? So that will be your simply a ring. So that will be our dl. Okay. So this is how I will define dl. So my dl will simply be a circle, or you can say ring. So this is my dl, which has a radius r. R you can say, or you can say rho as well, because on xy plane, this is on xy plane only, no? So on xy plane, how do we define the radius? We define as rho. Rho is equals to 1. So what is changing on this surface? If I take a small length dl, so what is changing here? So what will be my dl? Phi is changing. So that means rho d phi a phi. Are you getting this point? On this surface, what is changing? Phi is changing, no? If you walk in this direction, only phi is changing. And what did I tell you? Always you need to take a phi cap. Like always you need to take the positive direction a phi cap, right? Now what I need to calculate? I need to calculate f dot dl. So f is z ax cap plus ay cap plus y az cap. Z ax cap, z x y. Okay, z x y dot this rho d phi a phi cap. Okay. Now can you tell me one thing? What will happen? These will be dot product. Az dot a phi cap, ay dot a phi cap, and ax dot a phi cap. What is the value of z on this particular sphere? Sorry, not sphere. On this particular circle. What is the value of z on this particular circle? You are just calculating about this. You are only thinking about this base. You are only thinking about this base. And base is also a closed line. It is not a surface. Base is not a surface. Base is just a closed line. Base is just a closed line. So what is the value of z here? Z here is z equals to 0. Z is going from z equals to 0 to 1. But I am only talking about this ring. So on this ring, z is equals to 0. So here z is equals to 0. Right? So here z equals to 0 I can put. So what I'm gonna get, x ay dot a phi cap plus y az dot a phi cap, and outward you are having rho d phi. So a phi cap az dot a phi cap, ay dot a phi cap. Okay. Now ay dot a phi cap. Do you remember ay dot a phi cap? Because this was the reason why I asked you to remember these kind of formulas. If I am asking something to visualize, then you should visualize that. When we were studying coordinate geometry, I told you if you are able to visualize this much of thing, then you will feel very good in the examination. This was your a phi cap. What was your arrow cap? This was your arrow cap. And what was your a phi cap? This was your a phi cap. This was your angle phi. This was your angle 90 minus phi. This total angle was 90 degrees, so this angle was phi. So ay dot a phi cap is cos phi. So x cos phi. Z is always perpendicular to a phi, right? Z and a phi are perpendicular, so this will be 0 into rho d phi. And rho is constant, rho is equals to 1 here. Value of rho is 1. So x cos phi d phi you are getting. So what you are getting? X cos phi d phi. I could have put a closed line integration here. Okay. So value of x I need to put, which is x is equals to what? Rho cos phi. X is equals to rho cos phi. So rho is 1. So x is equals to cos phi. X is equals to cos phi. So cos square phi d phi. Now you need to take the limit. So phi is changing from 0 to 2 pi. Phi will change from 0 to 2 pi. So value of phi is 0 to 2 pi. 0 to 2 pi. So if you solve it, what you are gonna get? Whatever the limit you see upper side, just do by 2. This is what I told you, right? If you remember the previous lecture, some trigonometric formula I told. So whatever the limit you see, just do by 2. So what is the answer you are getting? Pi. So this is the answer of f dot dl. So very easily I am able to get the final answer. But this might not be so much satisfying to you, that you might be thinking that, sir, how I only took this projection. So this is something you can remember, that whenever you see a surface, whenever you see some surface and then some line, basically what we need to do is that on this particular surface you need to consider small closed lines. If you consider these small closed line, what is the meaning is that this is my sphere, you can consider sphere. So one small closed line I will consider, then one small closed line I will consider. Are you able to visualize that one small closed line I consider here, then another small closed line I consider here, here. So in this manner I am getting this pair. What will happen is that whatever the DL you are taking here, that will be getting cancelled out. Okay, so you do not need to think of the upper surface. You only need to take the lower one, or just you think that if I put this on a sand, then how it will look. This will be my DL. That's it. So upper one will be getting cancelled. So only with respect to this DL I am going to calculate. Or in the examination you can solve by this as well. Here there will be no doubt. In this solution there is no doubt. Just step by step we are going. Everything whatever that we know we are putting, and slowly we are doing the calculation and we are getting the correct answer. If we don't have that much of time left in the examination, if we think that okay, this hemisphere is given, how I should solve del cross of ds, I can apply inverse Stokes theorem. Okay, f dot dl I need to do. So how will I take dl? This is how I will take dl. What will be my dl? dl will be made from the bottom one as well and from upper one as well, but only this one will be left. Rest all will be cancelled. So only this I will take in action, and this is the answer I will get. Okay, just a second, just wait a minute. Yeah, so this is the answer. F dot dl is pi. So this was a good question. I hope you must have understood all the points behind that. Okay, so this is the scene. Let's solve the last question now. So this is the question you need to calculate. Very easy. A dot dl, closed line integration A dot dl you need to calculate. And what is your curve C? The curve C is the square from framed by x equals to plus minus 1 and y equals to plus minus 1 in clockwise direction. So in clockwise direction, x equals to 1 and x equals to plus minus 1. Basically the scene is, this is your x, this is your y. So what will be x equals to 1? This will be your x equals to 1. What will be x equals to minus 1? This will be your x equals to minus 1. What will be y equals to 1? This will be y equals to 1. What will be y equals to minus 1? This will be y equals to minus 1. Right? Right? Okay. And in a clockwise direction. So in this manner we need to work. Okay. And let's mark these points. 1 comma 1. This point will be 1 comma minus 1. This point will be minus 1 comma minus 1, and this point will be minus 1 comma 1. In this manner we need to go. We can mark the points A, B, C and D. A, B, C, D. Okay. Now it is a closed line. It is a closed line, so it is enclosing some surface area. So how will I apply the theorem? A dot dl is equals to del cross f dot ds. Then I will calculate del cross f, right? You can calculate del cross f on your own. Ax cap, ay cap, az cap, del by del x, del by del y, del by del z. What is the function? Y is equals to x square plus y square minus x upon x square plus y square, and this is 0. What is the answer you are getting? If you solve it, what is the answer you will get? Across ax cap 0, across ay cap 0, across az cap 0. So del cross f is coming out to be 0. So what you are thinking? That my A dot dl is equals to, since del cross f is 0, if you put 0 here, so my A dot dl is equals to 0. This is your answer. Wrong. Why is that so? Because what did I tell you? Stokes theorem is applicable if you do not get 0 by 0 or infinity form. Now in this particular closed line, this is enclosing this much of surface area. This closed line are enclosing this much of surface area. Now in this much of surface area, point 0 comma 0 is also coming. If you put point 0 comma 0, what is the value of A at point 0 comma 0? That is, if you put 0 comma 0 here, what you are getting? 0 by 0. That means here Stokes theorem is not applicable. Very important point. Okay. So in the examination, if you do these kind of mistake, you will lose 2 marks there. I guess not 2.66 you will lose. So whenever 0 comma 0 is included, always look at your function. Whenever you see these closed line, first you will see the closed line. Okay, closed line is enclosing this much of area. You will see the point 0 comma 0. If 0 comma 0 is there, then you will look at the function. At 0 comma 0, your A is getting undeterminate form. So Stokes theorem is not even applicable here. So if Stokes theorem is not applicable, then how will you find A dot dl? How will you find A dot dl? So for that, we need to solve. This is your curve C. So first I will go from, okay, so curve C is there. So let's make this curve as L. Okay, because C point I have taken here, no? So this I am making as L. So this is my curve L. So from A to B I will go A dot dl1. From B to C I will go A dot dl2. From C to D I will go A dot dl3. From D to A I will go A dot dl4. So what is my dl1? From where to where I am going? A to B. So dx ax cap. dl1 is dx ax cap. So if I calculate A to B, A dot dl, and here what is the value of y? Y is fixed at 1. Y is fixed at 1. So I am going from A to B. A to B. Okay. So y is fixed at 1 and dx ax cap I need to do. So y upon x square plus y square into dx, and y is fixed at 1. So 1 upon x square plus 1 into dx. And what is the limit of x? Only the limit of x I am going to put. So limit of x is from minus 1 to 1. Limit of x is minus 1 to 1. Minus 1 to 1. Can you let me know what is the value of 1 upon x square plus 1? Integration 1 upon x square plus 1. Do you remember it? Tan inverse x. Right? Tan inverse x. Minus 1 to 1. Tan inverse x, tan inverse 1 minus tan inverse minus 1. Okay. I do not remember what is tan inverse minus x. Tan inverse minus x. All student take copy. Tan inverse minus x should be minus tan inverse x. So it should give me pi by 2. Right? So this will give me, this minus sign can come outward. Tan inverse minus x is minus tan inverse x. I hope I am correct. Let me check it. Yeah, so it was correct only. Just I was confirming. I was sure only. I was just confirming. Okay, because on the screen I cannot write anything wrong. So this will be pi by 4 minus of minus pi by 4. So it will be pi by 2. Okay, so here you are getting pi by 2. Now what is your dl2? In dl2 what is changing? Y is changing. Always you will write down the positive direction only. Now you will not say that, sir, I am going towards a negative y, so I will write minus ay. No, limit will take care, because limit you will put from 1 to minus 1. So that will take care, right? And what is the value of x here? X is also fixed here, x equals to 1. On this line, what is the value of x? X is equals to 1. So x is fixed, x equals to 1. So what I need to do? A dot, this was your dl1, a dot dl2 I need to do. So y value I am getting from 1 to minus 1, and x value is fixed. X value is fixed at 1. So minus 1 y square plus 1. So minus 1 y square plus 1 into dy, right? So what I am getting? I can interchange the limit now because minus sign is there, so I can interchange the limit. So what I will get? Tan inverse y from minus 1 to 1. Again the same answer I will get, pi by 2. Right? Because this is the same thing only, tan inverse 1 minus tan inverse 1. So again pi by 2. What about dl3? So in dl3 what is changing? X is changing. So dx ax cap. So dx ax cap. What is the value of y here? Y is equals to minus 1 here. Right? So what I need to calculate? A dot dl3. So y is equals to minus 1. So minus 1 x square plus 1. Minus 1 1 plus x square dx. Okay, and value of x, how it is changing? From 1 to minus 1. Value of x 1 to minus 1. Okay, so what you are getting? Tan inverse x minus tan inverse x you will get, but you can interchange the limit because minus sign is there. So from minus 1 to 1. Again the same thing you are getting, again pi by 2. What about dl4? In dl4 y is changing. Y is changing. And what is the value of x there? X is minus 1. A dot dl4 I need to do. A dot dl4 I need to do. Y is changing from where to where? In dl4. Y is changing. In dl4. Y is changing from minus 1 to 1. 1, 2, 3, 4, minus 1 to 1. And what will be the value? 1 by 1 plus y square. Minus 1 to 1. 1 by 1 plus y square. Because x value is minus 1. Dot dy. So what you are going to get? Tan inverse y. Tan inverse y. And you will go from minus 1 to 1 only. So what you are getting? Pi by 2. So all 4 are pi by 2. Pi by 2, pi by 2, pi by 2 and pi by 2. So what is your final answer? A dot dl. That is pi by 2 is added 4 times. So answer is 2 pi. Okay, so yeah, that's it. Right, so this was something, our vector calculus. We spent a lot of time on vector calculus. I hope you enjoyed the session. Okay, so we have studied everything on vector calculus. We have studied coordinate geometry. First we studied vector algebra, then coordinate geometry, and then vector calculus. We studied first differential calculus, then we studied integral calculus. I hope you enjoyed the session. I hope you liked it. Now, electrical students, Thank you very much for attending the classes. It was roughly around 16 hours of content. You have consumed 16 hours of content. I hope you enjoyed the content. If you enjoyed it, do like it and comment down, because our journey will end. EMFT journey is not an ending. Anish sir will take care now. So Anish sir will get in touch with you and he will teach you electrostats and magnostat. EC students, journey is long enough there. Okay, long enough journey is still left, but we have covered the most complex part. This is actually one of the most conceptual part and complex part as well, which students do not understand. And if they don't understand this part, they are not going to understand EMFT. So we have covered good amount of parts. So our next chapter will be Maxwell equation and EMF for EC guys, for electrical and instrumentation. Thank you, EE. Like, it will be very unfair if I don't write IN. Really sorry, I forgot to write IN here. Okay, really sorry. Please, IN student, do not dislike this video. Please do not feel offended. So I'm really sorry I forgot to write IN here. So next topic for electrical and IN will be electrostats and magnostats. Now, no need to solve the PYQs of this chapter. Why I am saying so? Because this is not specifically mentioned in your syllabus, but this is useful and certainly question will also come. But you do not need to solve the PYQs, because in mathematics you will be doing enough practice. If you have studied mathematics, like if you are preparing for GATE, then certainly you will study engineering mathematics for sure. So if you have studied engineering mathematics, then you would have done enough practice. Now you would be more comfortable with this particular chapter, that is vector calculus and coordinate geometry as well. So if you have time left, then you can do the PYQs. If you do not have time left, then you can skip the PYQs as well, and there will be very less PYQs. And what if they will ask one question from this particular chapter, and they will ask a very good question as well. So in engineering mathematics, you will get these questions. Like whenever they frame a PYQ book, whenever they make the PYQ book, they will put the vector calculus questions in mathematics. They will not put the question in EMFT. That's why I am saying do not do the PYQs, because in mathematics you will get enough practice, right? So yeah, that's it from my side. That's it for this particular chapter. Now we are going to start our Maxwell equation and EM wave. There we will see the boundary condition as well. So this is our next chapter that we are going to start. So the journey of this vector calculus and coordinate geometry ends here, and I will be expecting a lot of comments from the students, how they found this content, like how electrical student found this content and how EC student found this content. Okay, thank you very much.